Hello there, college algebra students. This is Mr. Kashi speaking. This video we're going to go over a couple more slides with the 2-1 power and radical functions lesson. In this lesson we are going to be talking about radical functions. And there's really two ways to write radical functions. One is an exponential form that looks like that, and radical form that looks like that. We'll be mostly dealing with the radical form, but we're going to be taking a look at what the shape of their graphs look like and the different characteristics. Really, it's going to be important to know when we have when n is even and when n is odd, their graphs are going to look the same, as we can have a negative component when the root is an odd number. Down below here are some characteristics of these parent functions that we have, and just some things to refer back to as we go forward here. So this first one seems quite a bit involved. I'm going to walk through each one of these slowly, so don't get too excited. So here we're basically, remember, we're just plugging in things for plugging in values for x, kind of letting our calculator do the work. So in this case, we're having a fourth root. So the function is 2 to the fourth times the fourth root of 5x to the third. If you wanted to, this would be 2 times 5x to the third to the 1/4 power. Okay, but in this case, I mean, really, if we're using a calculator, it would help just to plug it into the radical form like this. This first one's rather easy. It's plugging in 0, you cube it, you multiply it, take the cube root of it, multiply it. It doesn't really matter. When you're plugging in 0, you're going to get 0 out. Because of this complicated function here, we're going to get some decimals, so our graph is going to be rather an estimate. So here we're plugging in, it's a 4. Plugging in a 1, and once you do that, you're going to be getting 2.99. Plug in a 2, and you get 5.03, so on and so forth. You're plugging in a 3, and you get 6.82. Plug in a 4, keep going this way, we got 8.46, and plugging in a 5, and we get 10. Okay, so here we have two pretty two points that we can put directly on the grid. So we have 0, 0, and then we have 5, 10. So we put these two right there. And just taking a look at this graph, it's almost pretty close to linear if you're to take a look at these points. So if we go 1, 3, basically 2.99, that'd be 3. Then we have 2, 2, 5. That almost looks like a line. Hopefully you can see how it's not linear. It's a little off there. It's not a straight line, but it'd be pretty close. Then we have 3 and 6.82, and it's almost closer to 0.5. But then we have 4 and 8.5 right there. So there's a little bit of a bend to our graph here, and it's going to keep going in that direction. And so obviously this is manipulating this x to the third and the fourth root of that, kind of the translation that we've been studying earlier. But just a couple of things that I'd like to point out. Our domain, our x values are basically starting at 0 and going up, so that would be including 0, because we could plug 0 in. Then we'd be going up to positive infinity. And our range is actually that identically. We starting at 0 here and going up for our range. So this would be domain and range. Range would be starting at 0 and going up to positive infinity as well. And we would have just intercepts. Our x-intercept would be 0 and our y-intercept would be 0 as well. And then lastly, just the one thing that I want to make sure that we understand is we're increasing. Is our graph going up or down? Increasing the whole time, which just means that it is the same as our domain. So we include 0 and go to positive infinity. So I just wanted to do that one kind of separate. The rest of the videos are going to be dealing with a lot more algebra, not as many graphs. So this would be the graphing of a radical function.